Welcome back. In this lecture, we're going to explore the oftentimes misunderstood world of vitamins. And I've had a patient come into my office and she just had chronic gastrointestinal upset, chronic diarrhea. And she went to the gastroenterologist and she had every test under the sun done. And finally, when she was sent to me to see if it was a food allergy or something else, we just talked about supplements. And I said, do you take any supplements, vitamins, minerals? And she said, well, yeah, I take vitamin C. Doesn't everybody? And actually, she was taking 10,000 milligrams of vitamin C. And the vitamin C was the cause of her diarrhea. Most of us don't think about a vitamin and diarrhea, but in this complex world of vitamins, we're going to explore just the consequences associated when too much of a good thing is not a good thing. But let's do a little bit of fact-checking here. Let's get our vitamin and nutrition under control. Well, again, the focus of this lecture is we're going to explore the types and roles of vitamins to kind of set the stage so we can study the functions, requirements, and even potential toxicity of these wonderful, essential, unique chemicals. By definition, vitamins are organic substances. Now, what does that mean? It means that they're carbon-based. It's not organic like they come naturally. They're not made with pesticides. Organic actually means they have carbon as part of the structure. Bodies, with one exception, can't manufacture vitamins. And so what that means is they must be consumed in your diet or through supplementation. The exception of the one vitamin that you can make is vitamin D. In the world of nutrition, 13 different vitamins have been isolated and classified. And in general, we put them into two major categories: fat-soluble or water-soluble. And we'll come back to water-soluble a little bit later. One of the key concepts, however, in vitamin nutrition is this word bioavailability. It is actually the amount of the nutrient that you absorb and you can utilize. So I want to keep you grounded here. If you look up all your vitamins in a database, or you're looking it up in a nutrition book, and something tells you it has 60 milligrams of folic acid, that's what's in the food. It's not necessarily what you can get out of the food. So we've got some factors that influence bioavailability. Certainly the form of the vitamin. Most of us, when we think of a vitamin, we think of a singular compound. But in the example of vitamin E actually has 8 different forms or isomers, and they're not all equally effective. There's also the difference between natural or synthetic. And most of the time, we think of natural as always being the better. And some of the science about vitamin E, they'll suggest that the natural version, the food-based version of vitamin E, is actually better for you than the synthetic. And we'll explore that in more detail later. With folic acid, synthetic is better. It is more biologically available. So although there's folic acid in food, when you think of folic acid, think foliage, green leafy vegetables. Synthetic folic acid, that's what's put into your breakfast cereal in the morning. Synthetic is more biologically available. Sometimes in the world of vitamins, a food or a food component could increase or decrease bioavailability. Folic acid, again, is better absorbed on an empty stomach than absorbed with food. In fact, synthetic folic acid on an empty stomach has a bioavailability of almost 100%. When I take it with food in a mixed meal, I have a mixed meal, not just my breakfast cereal, a mixed meal, the bioavailability actually goes down to about 85%. Certainly the bioavailability of iron, a mineral, is actually improved with vitamin C. So I always liken this vitamin and mineral nutrition component of like a house of cards. When I knock down one, I can really influence my body's ability to use, absorb, utilize another. So you've got to kind of keep that in mind. Okay, fat-soluble versus water-soluble. What are those definitions? Fat-soluble vitamins mean they dissolve and remain in the body's fat stores or adipose tissue. So for example, vitamin D, when I take in vitamin D, if I've got excess body fat, that vitamin D is sequestered or held in my body fat, making it less biologically available to other tissues within the body. Because they are fat soluble, that means you can store them, there's a less urgent need to have them on a daily basis. As a group of vitamins, fat-soluble vitamins include vitamins A, D, E, and K. Now, they should not be consumed in excess without medical supervision or without medical advice. I'm going to suggest to you, however, when we talk about vitamin D a little bit later, there's going to be some rules that we're going to bend there. Toxic reactions can occur at much lower multiples of the recommended dietary allowances than water-soluble. Most notably is vitamin A. The next time you look at your vitamin bottle and you look at the vitamin A content, it may tell you 100% of the daily value, and then in parentheses it'll say 40% as beta carotene. What they're actually trying to tell you is they've taken out the more active, in this case more toxic version of vitamin A, and replaced it with a precursor. Beta carotene in your body can be converted to vitamin A. So vitamin A is relatively toxic. Little nutrition trivia here. Some experts suggest that if you have one serving of polar bear liver, that's not on the menu at my house, but one serving of polar bear liver can cause death. So you got to be kind of careful with these fat solubles. Water-soluble vitamins, on the other hand, are vitamins that you probably need to consume a little bit more on a daily basis. They are lost in your urine, but keep in mind, and please remember this, just because I can urinate it out and I don't store it doesn't mean I can't have an undesirable side effect. So in this case, we always think of all these water-soluble vitamins, these stress vitamins, all these other types of water-soluble compounds. We think they get a pass. They don't get a pass. They are chemically active agents, and they don't go through your body without some kind of side effect. In general, these water-soluble vitamins act as coenzymes. These are small molecules that combine with a larger compound to form an active enzyme. So think about it as the grease in the machinery. It's the grease of the metabolic machinery. It helps you to use your metabolic pathways a little bit more effectively. So in essence, it accelerates chemical reactions that need acceleration within the body. Within this category of water-soluble vitamins, we have vitamin C, probably the most famous of the group, B1, which is thiamine, B2, riboflavin, B6, pyridoxine, niacin, sometimes also known as nicotinic acid, pantothenic acid, biotin, folic acid, and vitamin B12. So that's kind of a laundry list, and that'll be in your guidebook. If the diet contains less than 50% of the recommended value for a water-soluble vitamin, deficiencies can begin to show up within approximately 4 weeks. The excess of a water-soluble vitamin is voided via urination. So when you take your multivitamin in the morning, you use the restroom, and all of a sudden your urine has an odd yellowy green, actually what that is the water-soluble vitamins that are being excreted. Vitamin B6 is a water-soluble vitamin that can have a toxic effect. But wait a minute here, I thought toxicity was more associated with fat-soluble vitamins. Here's an example of otherwise. I had a gymnast who came into my practice, and I work in adolescent and sports medicine, so she came into the sports medicine side. And what ended up happening was she was doing something on the uneven bars, and she lost her grip. She couldn't hang on. And she actually fractured 6 vertebrae in her back, and that ended her gymnastics career, and she was an Olympic hopeful. What ended up happening was her coach decided that she was really tired, and yes, I said coach. Her coach decided she was really tired and said, I've got a great idea. Why don't you take some B vitamins? She took enough B6 or pyridoxine that she had a neuropathy, a numbness and tingling in her hands that caused her to lose her grip. And when I asked the coach, I said, is there any toxicity that you were worried about? And she said, oh, it's a water-soluble vitamin, no toxicity. She ended the girl's career by taking too much vitamin B6. These water-soluble vitamins are dispersed in general in body fluids, and they're not going to be stored to any great extent. The exception here again, and we're now seeing a pattern, some exceptions to the rules, is vitamin B12. You can actually store vitamin B12 up to 1 to 2 years in your liver. So again, an exception to the rule. They exert their greatest influence for about 8 to 14 hours after ingestion. So again, this is something that needs to be consumed on a regular basis, and then after that, their potency actually decreases. Again, keep in mind that urine color change can be within hours of taking a vitamin. Okay, now we got to talk about vitamin C. And I'm going to really look at this in a different view. Vitamin C in the common cold, is it a myth, a reality, or could it possibly be both? Well, let's talk about the functions of vitamin C, also known as ascorbic acid. I think it's important because it's one of the most popular supplements on the market today. Why did it gain all this notoriety? Well, it's linked with a Nobel laureate, Dr. Linus Pauling. And Dr. Pauling's thought, and others, is that the current recommended amounts that are published, that 100% of the daily value that you see on a vitamin supplement, that might be enough to prevent the vitamin deficiency disease and not quite enough to prevent chronic diseases that we're faced with in this day and age. Well, the history of vitamin C, Dr. James Lind, a doctor in the British Royal Navy, conducted an experiment in 1747 with two groups of sailors at sea. One group was given lemon juice with their rations. The other group, which was a control, didn't. And what they showed was that vitamin C in the form of lemon juice prevented the vitamin C deficiency disease, scurvy. It's the degeneration of skin, teeth, blood vessels, and what are called epithelial hemorrhages. You can get little pinpoint hemorrhages on your skin. Lind published his results in 1753, and the British Navy waited more than 40 years. Now that's a little disconnect, isn't it? 40 years to add lemon juice or lime juice to the standard rations for British sailors. And that's where they got their nickname limeys. Physiologically, what does vitamin C do? It's an electron donor for 8 enzymes. It means it's a chemical reducing agent or an antioxidant in both in-cell reactions, intracellular, and extracellular, outside the cell reactions. As an enzyme cofactor, it kind of, again, allows that enzyme to do its job a little bit better. Vitamin C aids in the synthesis of carnitine. Now, what is carnitine? Carnitine is a compound that helps to get fat through cell membranes. It is actually made from lysine and methionine. Remember those essential amino acids? Lysine and methionine are turned into carnitine physiologically, and again, vitamin C aids that process. It's needed for the synthesis of collagen, again, a structural protein. Collagen is essential in wound healing, and so that's where vitamin C gets its nice reputation as promoting wound healing, is it promotes collagen synthesis. It's needed for the synthesis of norepinephrine, which is a neurotransmitter. It's needed for peptide hormone synthesis, protein hormone production. And it's needed in the synthesis of tyrosine. Tyrosine, remember, is one of those essential amino acids. Now, as a chemical reductant, it aids in the enhancement of iron absorption from the GI tract. Iron needs to be reduced in order to be absorbed. And so this is where you hear people say, well, if you want to increase the absorption of iron, take it with a source of vitamin C. So for example, if you're eating a roast beef sandwich, you can get more iron out of that roast beef by partnering that with an orange, great source of vitamin C. As an antioxidant, and again, this is where some of the hype comes in, it, in theory, decreases the damage from free radicals and reduces some of the harmful reactions in the body. Now, if you remember back to the lecture on fat, we talked about these wonderful double bonds that were very vulnerable to the effects of oxygen. Vitamin C helps to protect cell membranes against damage. Now, certainly it maintains a significant role in producing cartilage, bone, and dentin, which are an integral part of tooth, the development of the tooth. So that's an important consideration as well. Okay, where do we get vitamin C from? Well, you're going to hear me say over and over again, fruits and vegetables are our plant-based heroes. And so, for example, a fourth of a medium cantaloupe has 60 milligrams. Half of a grapefruit, 40 milligrams. Certainly a half a cup of grapefruit juice, if you're following that, I'm going to stay in that 4 to 6 ounce range, 35 milligrams. Vegetables are a good source. Again, any fruit or vegetable is going to have vitamin C. Half a cup of cooked broccoli, 60 milligrams. A cup of canned sweet potato, 50 milligrams. So again, another great reason to eat lots of fruits and vegetables. In the American diet, the potato actually serves as a reliable and dependable source. Why? Because Americans love potatoes. So we eat a lot of them and they become a good source of vitamin C. Okay, well, you know the numbers, but how much do you need? Okay, let's talk about that RDA, that recommended amount that you should have every day. What does that mean? RDA means it's sufficient to meet the requirements of nearly 98% of healthy individuals in particular life stages and gender groups. So most people believe that when you look at the daily value on a vitamin, it only covers 50% of the population. That is not true. The other thing that is not true about interpreting that vitamin label, the other thing that is not true is that somehow if you're ill, that level of vitamin is going to cover you. Remember, it covers nearly 98% of healthy individuals. There is no daily requirement for individuals who are ill, and I think that's where some of the issues come in. Requirements certainly can change throughout the life cycle, and again, these values are only reasonable for healthy people. Okay, so say for example, you've sustained a major burn, and I'm not talking about the burn at your kitchen stove, but a significant burn. There are some people who believe you need up to 2,000 milligrams of vitamin C. Well, let's compare that to what happens when you're healthy. A male in the age range throughout the life cycle of 19 to 90 requires about 90 milligrams, and females, again, same age group, 75 milligrams. So think about that combination of fruits and vegetables. It's not too difficult to come up with that range. And you can look in the guidebook for more values. Now, here's where it gets a little fuzzy. The National Cancer Institute has issued a position that more than 150 studies have clearly shown that groups of people who eat plenty of fruits and vegetables get less cancer at a number of cancer sites. What are they recommending? The NCI encourages the consumption of 5 or more servings of fruits and vegetables, 9 for men. And keep in mind that's a lot of fruits and vegetables similar to the DASH diet. So I want you to think here on how nutritional science can evolve. What that can mean is people think, aha, what's in fruits and vegetables that's contributing to this reduced cancer risk? And so the quantum leap is that because fruits and vegetables are a great source of vitamin C, it must be the vitamin C. And over again in clinical nutrition, we've made that quantum mistake. We believe it's one compound in fruits and vegetables, in this case vitamin C, that's responsible for the reduced risk of disease. It's not the case. Okay? Additionally, our government will suggest, the U.S. Dietary Guidelines will suggest 2 to 4 servings of fruit and 3 to 5 servings of fruits and vegetables daily. Clearly, this is enough to meet the vitamin C requirements. However, interpretations from the NCI and the USDA guidelines always suggest that it could be the vitamin C in fruits and vegetables. I'm going to suggest to you it's probably not that. Vitamin C may be an important component in disease risk reduction, but what's unique about fruits and vegetables? In another lecture, I suggest that you choose your fruits and vegetables based on the colors of the rainbow. And emerging science suggests it's the colors in the plants. Maybe not the vitamins and minerals, but the colors in the plant. It's the blue in the blueberries. It's not the vitamin C in the blueberries, it's the blue in the blueberries that actually may give you the best disease reduction. So again, over and over again, some of the supplement studies fall short, where the food-based research studies, the NCI-based publications, are going to suggest more fruits are better. Now, certainly some populations need more or less vitamin C than others, and the need varies with other factors such as health status and lifestyle choices. So again, for individuals engaged in strenuous exercise, experience frequent viral infections. In fact, you can take a look at individuals post-marathon and you see this spike in viral infections post-marathon. Some studies suggest that daily supplements of 500 to 1,500 milligrams of vitamin C may protect against upper respiratory infections in this group. So that's significantly more than the daily value, isn't it? Certainly other lifestyle factors, and this is a negative one, but individuals who smoke or are individuals who experience secondhand smoke need about 1.5 times the normal amount. So for female smokers, at least 95 milligrams per day, and for male smokers, at least 110 milligrams per day. So that's a great example of 2 stages in your life, one being great, although that wonderful exercise, and one being not so great, individuals who smoke and their vitamin C requirements have changed. Now, what about excess vitamin C? What happens if you decide to step outside the norm? Well, it's relatively non-toxic. However, again, keep in mind it's a water-soluble vitamin, but it doesn't mean it doesn't have an effect. There are some studies that suggest it's possibly linked with an increased prevalence of kidney stones. Well, how does that happen? In the metabolism of vitamin C, it's metabolized to a urinary product called oxalate. And many of the kidney stones that people can develop, many of the kidney stones are oxalate-based stones. Now again, with most things in clinical nutrition, there's some conflicting research, but in general, keep in mind these are individuals that are consuming 1,000 milligrams a day or more. Now certainly some African Americans, those of Jewish heritage, some of Asian descent, may actually have a genetic metabolic deficiency that with excessive vitamin C intake creates what's called hemolytic anemia, that the red cells rupture and lose their iron content. Now, in individuals with iron deficiency, megadosing vitamin C, taking up to 10 times the amount that you need, can destroy significant amounts of vitamin B12. So that's an unusual twist. Too much of vitamin C actually affects the bioavailability of vitamin B12. In healthy people, excess vitamin C can cause bowel irritation, and I've given you the example of chronic diarrhea with excess vitamin C intake. Now, to me, as a clinical dietitian, one of the most disconcerting things with excess vitamin C is it can interfere with other diagnostic tests. So if you've ever had a colonoscopy, if you've ever had the test called fecal occult blood in the stool, if you've ever had any of those tests, if the doctor is trying to say, okay, are you going to be a candidate for a colonoscopy or not, he may take a look at how much are you losing any blood in your stool. If I'm taking a lot of vitamin C, it can actually interfere or react with the reagent that's testing for blood, and actually it gets confused. So the bottom line is, if I'm taking a lot of vitamin C, it can show that I have blood in my stool when I don't. So now I'm going to be in line for a colonoscopy that I really don't need. It can also interfere with the test for glucose or sugar in your urine. It can show that you have sugar in your urine when you don't. It's just the excess amount of vitamin C. So interestingly, we now have this new concept in clinical nutrition of what should our upper limit of intake be. And the upper limit for vitamin C should be about 2,000 milligrams. So keep that in the back of your mind that if you decide to step outside the daily value, you really want to stop when you get to 2,000 milligrams. Okay, what about vitamin C and common illnesses? Can vitamin supplements prevent chronic disease? 30 studies involving almost 10,000 respiratory episodes, so these are individuals who have been sick, have contributed to a pooled research study on the length of the common cold during infections. And here are the results. Individuals who are taking a lot of vitamin C to prevent upper respiratory infections, it can actually reduce the duration of a cold by about 8% for adults and the range of 13 to 14% for children. But it doesn't necessarily prevent the cold, it's just going to shorten the duration of the cold. So in other words, it doesn't make your cold any less rigorous, it just shortens the duration. So that's kind of a little bit disappointing news because Linus Pauling came out and said vitamin C is going to prevent the common cold. And the science now says probably not true, but it may shorten the duration of the cold, but not necessarily the intensity of the cold. Some really exciting research looks at age-related eye disease, and it's called the ARD study, indicated that taking 500 milligrams of vitamin C, in addition to other dietary compounds that function as antioxidants, and zinc, indicates the reduction of that disease. So now you see supplements at the store that are based on that AREDS study, suggesting that vitamin C may really help to prevent that debilitating disease. Certainly, again, cancer, plant-based diets can aid in the prevention, but most of the supplement studies looking at the prevention of cancer and heart disease are proving to be less than effective. So I think the real challenge is, if we're going to look at this and summarize this, is vitamin C is a nutritional powerhouse. It is an antioxidant. It helps the absorption of nutrients. So we can't make that step between if it's great in a food-based form, that somehow a supplement, I can supplement my way to good health. So think about this. Have you known individuals who say, you know what? It doesn't make any difference if I only eat fast food. It doesn't really make any difference if I change my dietary quality at all. I don't have to change the quality because what am I doing? I'm taking a supplement. And so when you look at individuals who take vitamin C supplements, they really are doing it for the fruit-based benefits or the vegetable-based benefits, but they're not getting those. So over and over again throughout this course, we're going to discuss some of the challenges with trying to dissect out the active component of fruits and vegetables and put it into a pill. Well, why do Americans want to do that? We want something that's quick and easy. We want something that's convenient. And I'm also going to suggest what we want to do is protect our health. And what we're learning is that the protection of health really occurs on the plate. So in order to get this best balance of vitamins and antioxidants, the National Cancer Institutes and other organizations are suggesting organize your plate in the most effective form. So how do we organize our plate? The way I suggest that people do it is draw a line down the middle of their dinner plate. Not literally, but imagine a line down the middle of their dinner plate. And 50% of your plate should be fruits and vegetables. This works no matter where you go. You're getting wonderful amounts of vitamin C. You're going to get some wonderful other antioxidants. And clearly, given the vitamin C requirements, we can easily meet our vitamin C requirements with that half a plate fruits and vegetables. Okay. Frequently asked questions. Now remember, we have a love affair with vitamins. And so what do we know about these new vitamin-enhanced waters? Well, I have to tell you, I really wished I would have made that up because I would be retired. Unbelievably popular concept. Many vitamin waters start out basically with a sugared watered solution. They might have some pomegranate juice in it or orange juice or other kind of fruit beverages, but in general, it's not going to be 100% fruit juice. And they add vitamins and sometimes minerals to them, or they'll add some other nutritional bonuses. So reflecting back on what we just covered, we have really very little data saying that we can supplement ourselves to good health. So why are these waters so attractive? Because Americans believe that we live in a deficient society. And in essence, if you, again, just reflect back with how little vitamin C you need, the reality is you don't need to take a vitamin-enhanced water. The way that I see them used, particularly by teenagers, is just what I mentioned. I can eat fast food. I can, not exercise, but I'm going to have my wellness needs covered by taking a vitamin-enhanced water. So to me, it's vitamin-enriched Kool-Aid. And again, if you're vitamin deficient, it might be a good way of getting it. If you can't take a vitamin for whatever reason, that might be a weak alternative. But I think that the real challenge is to believe that supplementing our way to good health is the way that we're going to go. And clearly the data doesn't support that. Well, as you start to unravel in your mind some of the intricacies of vitamin supplements, you now should start to ask yourself, well, wait a minute here. Can a medication or another vitamin influence my vitamin C status? Certainly, we know that vitamin C can enhance iron absorption, and that's a really good thing. However, there is concern with the interaction of prescription drugs. Some studies suggest that vitamin C can interfere with prescription medications such as warfarin, which is used to thin the blood, making them less effective. So again, think of that house of cards, or maybe think of a domino analogy. When I knock one down, I'm going to affect my body's ability to use something else. And in this case, if you're on warfarin or a blood thinning drug, you're using it as a life-saving treatment, and you don't want to end up taking a bunch of vitamin C. However, of most concern is the recent evidence that large amounts of vitamin C may interfere with standard chemotherapy for cancer. The theory is that vitamin C will accumulate in the cancer cells. And how does it function? It functions as an antioxidant. And what it's doing is protecting the cancer cell from the damaging effects of chemotherapy. Now, from a cellular standpoint, to the cell that makes a lot of common sense. To as the cancer patient, You don't want to protect that cancer cell from damage. In fact, you want to shut down the mitochondria, the energy-producing machine. And research at the Sloan Kettering Institute indicates that the addition of vitamin C could reduce the effectiveness of many standard chemotherapeutic agents by up to 70%. So again, the real tragedy is you may have someone who's taking vitamin C to protect their health, to safeguard their health, and in essence, they're compromising their effective treatment. So again, this is the reason why if you decide to step out of the norm and take significantly more than what's recommended, what you need to do is stop, talk to your healthcare provider, and again, maybe explore some dietary ways of getting vitamin C and other nutrients as well. Get the whole package. Thank you very much.